SOLIDWORKS Plastics 2017 provides more flexibility and control when defining your plastics design studies, as well as better performance and accuracy for interpreting those results. Let's take a look at some of the many new features found in SOLIDWORKS Plastics 2017. The first thing you will notice is a more unified interface, mimicking that of the rest of SOLIDWORKS, including the new icons introduced in SOLIDWORKS 2016 and refined in this release. There's now a setting focused on load time performance for files that contain SOLIDWORKS Plastics information. This option now allows you to defer loading SOLIDWORKS Plastics data until you activate the SOLIDWORKS Plastics tab from the Feature Manager. Once activated, SOLIDWORKS loads the needed information on demand. There are now new enhancements when working with configurations in SOLIDWORKS Plastics. You now have the ability to work with derived configurations, giving you more ways to work with different design criteria. Now let's take a look at some of the new options available when defining a SOLIDWORKS Plastics design study. The first thing you'll notice is a new option that allows you to leverage your previous design data. You no longer need to start from scratch when redefining the study. This saves information such as cavity, runner, cooling, and domain definitions previously defined. However, in this circumstance, we do want to look at some new options in those previous steps, specifically for defining a runner system. To do this, we'll activate the runner and cooling system design option. Once this is loaded, we'll activate the runner system design and remove all of the previous information that was saved from before. In this case, I would like to show the new draft angle option available when defining the runner system. This new option gives you more ways in which to define the elements of your runner system when start and end values don't meet your specific needs. In this specific example, we've selected the three lengths where the runner system interfaces with a cavity, and the draft is applied to those segments automatically. This new option can be used in combination with the previous definition method where you can specify start and end value. For this example, we'll add a few more lengths of runner of varying size to get exactly what we're looking for. Finally, we will end again using draft for where the runner interfaces with a sprue. Once that's finished, let's take a look at some of the powerful new options available for surface mesh creation, which include new refinement options. SOLIDWORKS provides the ability to control the mesh through a nominal size, but now you have new ways in which to refine this definition. With Automatic, SOLIDWORKS will refine the mesh around areas of high detail in your design. Assigning size allows you to specifically define mesh size in specific areas of your design. Or using Automatic and Assign, you can use a combination of the two, which offers the greatest flexibility. In this example, we'll refine the mesh around this boss in the corner of the cover, as this might be an area we really want to understand in more detail. You may also notice that SOLIDWORKS has conveniently turned on selection filters for us, making this process even easier to select the faces. Once finished, we will let SOLIDWORKS create the mesh using the parameters we've applied. Once the mesh has been created, you can see the nominal 3mm mesh size throughout most of the design, with a refined mesh automatically applied around high detail areas, and finally the mesh we specified applied to the boss in the corner. Now that the surface mesh has been applied, we will quickly remove through the rest of the setup process so that we can create the solid mesh from the surface. This will take a few moments to solve, but we want to make sure we show some of the powerful new options available when adding injection locations to the design. Once the mesh has finally been created, we'll again navigate through the rest of the setup procedure and let SOLIDWORKS save the SOLIDWORKS plastic setup files locally. This is something sometimes overlooked. It takes a moment, but it always allows you to return to your simulation setup at any time. Once the mesh has been complete, we're ready to define some of the injection characteristics for the runner system we created. To start, I'll just add a simple injection point to the top of the runner system, like I would normally using an injection diameter of 10 millimeters. However, there are now new options for defining the injection process, specifically a new control valve option. These will be the locations where our runner system interfaces with our cavity. You can choose to manually select those locations, but SOLIDWORKS Plastics has a convenient new feature to automatically select them for you. In this case, you can see that SOLIDWORKS has found the 3 locations mentioned previously with no effort on our part. Even better, within each control valve you have more refined control to specify when the valve opens and closes. From the pull down you can choose from volume ratio, which activates the valve based on what percentage of the cavity has been filled for both open and close. You can also choose to manually specify the time at which the valve opens and closes. And lastly, a powerful option to automatically determine the optimal open and close times for the valve. Regardless of which option you select, the open and close times will be available in the flow report generated once the study has been run. In this example, we'll specify that the center valve should wait until 30% of the cavity's volume has been filled through 100%, or the rest of the cycle. At this point, you would now run your fill and pack analysis based on the settings you've provided. However, for time's sake, I'll switch to a configuration where I've already run the simulation. Now that the configuration results have loaded, let's take a look at some of the new options available for interrogating our results. One of the first things you will notice is the inclusion of minimum and maximum results next to the results display, giving you better insight into these values. As you change the values, those will remain visible for reference. There's now also more refined control over the speed at which results animations are shown, so you can slow down or speed up the results to get a better understanding. Here is where we can also see the delayed opening of the control valve that we specified previously. Notice that it doesn't start supplying material to the cavity until it's already 30% filled. There are also some slight changes to the display of weld lines. Specifically, now the colors are more representative of their condition. Red is where the melt front meets at small acute angles, while blue is where the melt front meets at large obtuse angles, making it easier to interpret how the weld lines are being formed. Finally, there's a new powerful form of XY plot available that provides insight into mass versus time over the duration of the injection process. This chart makes it easier to understand how the injection process is performing throughout the cycle and specifically differentiates the flow and pack cycles so you can understand mass contribution from both. As we've seen, SOLIDWORKS Plastics delivers much more flexibility and control with tools that provide more insight into the overall performance of our designs as they relate to the plastic injection process.